Hello everyone. Today we are going to analyze JEE Main 2025 January 22 Shift 1, the morning session, right? So this session, this video will be helpful for the students who wrote this test to check their answers and also who are going to write the upcoming JEE Main question papers, right? So without any further delay, let's get started with the first question. The correct decreasing order of electronegativity. What is electronegativity? Electronegativity, that is attraction of paired electrons towards itself. So what is the decreasing order of electronegativity? It's none other than fluorine and then chlorine and then goes to Br and then iodine. So very simple question. So hope you did that right. Let's see this question. Which of the following lanthanide has 7 electrons in the outermost shell? Europium 3+, gadolinium 3+, europium 2+, and gadolinium 2+. So we know that europium, which will not have 7 electrons in the outermost shell, that will have after xenon 4f6, and for gadolinium 3+, it becomes after xenon 4f7. So this will be the correct answer. Let's check for europium 2+ as well, which becomes after xenon 4f5. So the answers to this question, that is gadolinium 3+. This question, for nickel Cl4 2-, what is the charge on the metal and the shape of the complex? This is a very straightforward, easy question, isn't it? So nickel Cl4 2-. So the charge is obviously nickel 2+. Right? For nickel 2+, what would be the electronic configuration? After argon, 3d8, 4 is 0. So this is a weak field ligand. So it will not undergo pair up against the Hund's rule. So this will be obtaining the position of like this, isn't it? So the hybridization starts with 4s orbital. So the hybridization is sp3. So it becomes tetrahedral. So +2 tetrahedral, that is the answer to this question. Let's move on. Electrolysis of which compound give H2S2O8? So the options are electrolysis of concentrated NO2SO4, electrolysis of dilute sodium sulfate, concentrated sulfuric acid, dilute sulfuric acid. It seems like a NCERT question, isn't it? But it is not. So they gave a twist in this question from the NCERT question. So electrolysis of concentrated sodium sulfate, it will produce oxygen at the anode and H2 at the cathode, isn't it? So there is no formation of H2SO8. What about dilute sodium sulfate? In this case, again O2 and H2 will be produced. There is no formation of H2SO8. And talking about electrolysis of concentrated H2SO4. So it produces in the cathode reaction, that is H+ takes up 2 electrons, gives H2, and as a anode reaction it gives 2 HSO4- gives H2S2O8 plus 2 electrons. So it forms peroxo disulfuric acid, that is none other than H2S2O8. So this becomes the right answer to this question. And talking about dilute H2SO4, it is also producing O2 and H2 at the anode and cathode respectively. So answer to this question is option C. Then Compare the boiling point of the given solution. So 10 to the power minus 4 sodium chloride, minus 3 sodium chloride, minus 2 sodium chloride, and 10 to the power minus 4 of urea. So first of all, what we have to consider about the boiling point elevation. So boiling point elevation is depend on the concentration of the solution and whether the solute is electrolyte or non-electrolyte. So boiling point, you have to consider about the concentration or electrolyte or non-electrolyte. Also we have to consider about the Van Hoff factor. That's it. So in the crash course also we talked about this Van Hoff factor I. So for NaCl solutions, that is an electrolyte or not? Yes, that is. So it is an electrolyte that dissociates as Na plus and Cl minus. So Van Hoff factor becomes 2. So the concentration, talking about concentration, 10 to the power minus 2 will take more concentration, and then 10 to the power minus 3, and then 10 to the power minus 4. So if I am talking about urea, is it an electrolyte? This is a non-electrolyte. So in that case, it will not dissociate. So the I factor, Van Hoff factor, that becomes only 1. At the same concentration, we will have low boiling point than NaCl. So the correct order will be 10 to the power minus 2 NaCl, and then comes minus 3 NaCl, and then 10 to the power minus 4 NaCl, and finally 10 to the power minus 4 of urea. I'm not sure about this was the exact question asked in the question paper, but this is what the question we got. Then the next question, CO2 plus carbon gives 2 CO. If final initial pressure of CO2 is 0.6 atm, then after equilibrium is established, the total pressure is 0.8 atm. Then find Kp. So that is the question asked. So how to solve this from equilibrium? The initial pressure of CO2, that is 0.6 atm. So the initial pressure of CO, that is 0. Total pressure at equilibrium, that is becomes 0.8, that is total pressure. .8. So let's say the pressure of CO2 is X. That reacts to form 2X of CO, right? Because here we have 2. So how to solve? So pressure of CO2 at equilibrium, which is equal to 0.6 minus X, because we don't know the pressure of CO at equilibrium. Then pressure of CO at equilibrium, that is 2X, isn't it? So the total pressure will become total pressure, which is equal to 0.6 minus X plus 2X, that is equal to 0.8. 0.8 is given in the question. So just find out the X. As simple as that. So just do the calculation part. So you will be ended up with 0.2 into 2, so which becomes 0.4 atm. Okay, So for the reaction, they are asking for the Kp. So Kp, which is the pressure of CO2, sorry, reactant divided by the product divided by the reactant. So which becomes 0.4. So answer to this question is option A, 0.4. Then there are two statements given, CH3OCl2Cl, which will show nucleophilic substitution by SN1 mechanism in protic medium. We already talked about a lot about SN1 and SN2 mechanisms, on why that is happening, what are the factors affecting it in the crash course itself. And the statement given, that is this is a tertiary carbon, point to be noted. Okay, so which will not undergoes nucleophilic substitution via SN2 mechanism easily. So which is correct? This is a primary carbon, will show nucleophilic substitution by SN1 mechanism in protic media. Is it right? While it is a primary carbon, the presence of O group is crucial and they are doing their work. So which becomes in protic medium, the resonance stabilization becomes particularly important, isn't it? So it can proceed. I gave you the table, isn't it? So what favors SN1 and what favors SN2. So it can proceed to the SN1 mechanism, and obviously statement 2 is correct by seeing itself. So this will not undergo nucleophilic substitution via SN2 because SN2 is favored by primary, secondary and tertiary. Okay, so answer to this question will become statement 1 and statement 2, both are correct. And which of the following acid is a vitamin? Saccharic acid, aspartic acid, adipic acid and ascorbic acid. So ascorbic acid, it is commonly known as vitamin C. So which is the right answer to this question? Other acids are not vitamins. They are either the synthetic sweeteners like saccharic acid and aspartic acid, or a common organic acid, that is adipic acid. Then the next question, which of the following electronegativity order is incorrect? So what is electronegativity? Once again, the attraction of paired electron towards itself, isn't it? So which makes magnesium, beryllium, boron, nitrogen? I'm sure you must be rocked this question. This is the simplest one. So which makes the answer to this question, that is Al, then comes magnesium, then boron, then nitrogen, that is the incorrect order. Because aluminium, the electronegativity is 1.6, magnesium 1.3, boron, that is 2, and then nitrogen, that is 3. Also, the electronegativity increases moving along the period and decreases as we are moving down. Which will show positive to the Fehling's test? Let me give you the options as well. The first option, that is benzaldehyde. The second option, that is acetophenone. The third option, that is C6H5, CH2, CHO, and D is CH2, C2H5, CHOH, CHOH, CH3. So which will give positive to the Felling's test? So Felling test mostly. So aldehydes will give, we do have two aldehydes over here, A or C. Obviously, benzaldehyde will not undergo Felling's test. We have talked about that, and which makes option C is the right answer. Then, the Lysines extract is boiled with dilute nitric acid before testing for halogens. Because, why is it so? First of all, what is this extract? It is a mixture of metals and their sulfides, which will contain sodium cyanide and sodium sulfides, Na2S and NaCN. And this is used to test halogens, is it? So Na2S reacts with nitric acid. Nitric acid is given, so nitric acid which will produces hydrogen sulfide and sodium nitrate. So that could interfere the halogen test. And also, if I'm talking about NaCN, sodium cyanide, that reacts with nitric acid to produce hydrogen cyanide and NaNO3. So that will also interfere the reaction or contaminating the sample. So by boiling the extract with dilute nitric acid, those two will get decomposed. So which will not interfere the reaction, so that we can properly test that solution. Let's say this question, the IUPAC name of the given compound CH3CHCOOH, CHCOOCH3 with another CH3. Okay, so what would be the name of this compound? First we have to think about the priority order. Is it? So the first priority goes to acid group. So I'm numbering it from here 1, 2, 3, 4. So 4-methoxycarbonyl, and second and third position I'm having a methyl group. So 2,3 dimethyl, 4 carbons are there, butanoic acid. So that is the answer to this question. Let's move on to the next question. Find out the incorrect statement. So this question I'm not sure whether the question is right or not. So please let me know in the comments below. Why I'm saying that? Because I'm getting two answers right. Let's see that. So melting point of cis-2-butene is greater than trans-2-butene. Is it right or not? It is an incorrect statement, is it? And then 2-methyl-2-butene. 2-methyl-2-butene, which makes butene can have two geometrical isomers. Is it right or not? That is an incorrect statement. Two CH3 groups are there in the same carbon. So that is also your incorrect statement. Not sure about the first one. If that is true, then two options becomes the right answer. Then the next question, for nickel Cl4 2- and nickel carbonyl, what was the change on metal oxidation state and shape of the complex respectively? So we already talked about nickel Cl4 2-, that is nickel 2 tetrahedral. And then what about carbonyl? So wherever carbonyl comes, the metal state, the oxidation state becomes 0. So that is makes the answer nickel 2 and tetrahedral. And what about the oxidation state of nickel in the carbonyl complex? So it will have after argon 3d8, 4s2. So 8 electrons over here. Then here I'm having 2 electrons. So this is a strong field ligand which makes the pair up, which will lead to no other changes. So that again produces sp3 tetrahedral. Then the next question, which is asking for the given NH2COO NH4 equilibrium with 2NH3 plus CO2. If the partial pressure of CO2 gas at equilibrium is 0.4 atm and the total pressure is 1, then the value of Kp at the same temperature is. So once again you need to use the same equations. PCO2, that is 0.4 atm, the total pressure given, that is 1 atm. So solid thing, this will not affect the Kp, is it? So which makes the total pressure, that is only concerned about the ammonia and CO2. So the Kp will become pressure of ammonia 2 is there, and then CO2, which makes, this is, let me take it as X, that is 0.4, which makes it pressure of ammonia, that is 0.6. So finding the Kp value, that is 0.6 to the power square, and then comes 0.4. The reactant solid, that will not affect, so which makes it 0.36 into 0.4, that is 0.144 atm. So atm cube. So that is the answer to this question. Compare the splitting energy of these four. Okay, when the splitting will happen? When the strong field ligands are there, right? So what are the strong field ligands we are having? CN, that is a strong field ligand. So strong field ligand causes high splitting, isn't it? And then comes ammonia. So ammonia, that is a weaker ligand, then when we are comparing that to cyanide. So that is kind of okayish. Then let's move on to SEN minus. So this is a moderate ligand, causes moderate splitting. It's not strong as CN. Then comes EN, ethylene diamine, is a weaker ligand. So considering CN and EN, ethylene diamine, so which will becomes a right answer? The first one is, then comes the fourth one. The answer is option A. Let's say this question asking for predicting the product. So what is the reaction given over here? That is NO2 with SnHCl gives A, and then NaNO2 plus HCl, that is giving B, then C2H5OH, that is giving us C. So what is the product C? So first we have NO2, that will give you ammonia, amine at the time of reduction. This is a reduction reaction, is it? So after that NO2HCl, that is giving us a diazonium salt. Then CH2OH, which will produce us benzene, plus N2 gas will be released. The number of linear compounds in a given list of compounds: I3 minus NO2, O3, OF2, NO2 plus BeCl2, N3 minus, and SO3. So let's quickly giving this structure. It is linear, right? So linear because that is having the 3 iodine atoms connected in a row, right? Talking about NO2, NO2 it's angular or bent, so it is not linear. Again, talking about ozone, that is also bent, not linear. OF2, that is also bent. What about NO2 plus? It takes a linear position and it undergoes resonance as well. Talking about BeCl2, that is linear, we know that very well. And N3 minus, once again, that is having a linear geometry. So SO3, that is trigonal planar, that is not linear. So how many compounds becomes linear over here? 1, 2, 3 and 4. So answer to this question is 4. Then predict the product weight. So what is the product given over here? That is NO2, that is undergoing SnHCl, then NaNO2 HCl, third is CuCl, and fourth one, that is sodium with dry ether. So we already did these two, which will give you amine, the aniline. Then it proceeds to diazonium salt. Then comes our Sand-Meyer reaction, CuCl, that will give you chlorobenzene. Then sodium with dry ether. What is this reaction? So which comes in halo chapter. We talked about it. Fitting reaction, is it? So which will form you higher order of the same alkanes. So that is diphenyl or biphenyl. So what is the product weight? What is the molecular weight of this compound? That is, just count the carbons and hydrogens, then you are done. So which is 154. Calculate the number of stereoisomers for CH3, CH double bond, CH, CHOH, CH3. Okay, how many chiral centers are here? Let me write it in this way. So how many chiral centers are here? This is an chiral center, is it? So, and then what about the geometrical isomers? So one chiral center, 2 to the power 1, that becomes 2, that is for R and S configuration. Do we how it will exhibit geometrical isomerism? Because this is having 2 different groups at the same carbon, so it can give cis and trans, so which makes the total isomers of 4. In Carrier's method, 180 mg of organic compound gives 143.5 mg of AgCl. Find the percentage of Cl in the organic compound. So let's do this with Carrier's method. In AgCl, what is the mass of Cl? Mass percentage of Cl, that is 35.5 out of 143.5. Is it? So the mass of Cl here, that is 35.5. Then you just need to calculate it from total 180 milligram of the organic compound. So which makes it 180 into 100, that is 19.7. So they are saying nearest to integer, so which makes 20% as the answer. This question, 2 ampere current is allowed to pass through the molten AlCl3 for 30 minutes. Find the mass of aluminium deposited in milligram at cathode. So the current is given, that is 2 ampere, then the time 30 minutes. So minutes converted to seconds, 30 into 60, it becomes 1800 seconds. So we know that Q is total charge, which becomes I into T, 2 into 1800, which will give you 3600 coulombs. So finding moles of aluminium, the Q by NF. So N, that is aluminium is in 3 plus state, so which becomes 3, and then F value 96,500, so which takes prox to 0.012 moles. So the mass of aluminium becomes, the molecular mass of aluminium, the atomic mass of aluminium, that is 27. So 0.012 into 27, that is equal to 0.33 grams. So if I'm converting that to milligrams, which will become 35.8 to the round off figure, that becomes 336 milligrams. So that is the answer to this question.